Alright, so today we're going to be measuring the concentricity, position, and flatness of each station at the furthermost dial of a 4-station index table with a dial plate. We set up an indicator dial, and it's just a regular dial hole furthermost from the center. We set up an indicator and we locate it downwards inside of the hole, and we call the first hole our 0. And all we're going to do is watch this indicator as it moves, and it's going to give concentricity in and out motion as we index this around the 4 stations. And if we ideally, if we hit this indexer repeating 4 stations, we want to see 0 on this indicator at every dial as we drop inside of it. So at setup, we're at 0, and we set our depth on the other side, which you can't see. We bring it outside, and we go and we index the table. Once the harmonics stop and it's in station, we can lower the indicator for the next dial. Theoretically, it should be in the exact same position, down to the same height, which we are. And we can look at the indicator, and we want to be as close to 0 as we can. This one, we are about 1/2 of a thousandth in the negative direction. So we'll record that per station, bring it up outside of the dial, and we'll index the next station. Same process. This one is actually at 0, so we're good. And we'll go to the 4th station. And it's that simple. This is also at 0. So 3 out of the 4 stations were at 0, and 1 was clocked 1/2 of a thousandth in the negative direction. So right now, we're setting up, and we're going to measure what's called position of the dial. So in regards, we just measured concentricity, which is the in and out motion. This is the measurement which is perpendicular to that. So if you were to come out, straight out to the dial from the center, that's your concentricity, and we're measuring the axis position, which is perpendicular to that. So if it's a little to the left or a little to the right, it'll show up on this indicator dial. We do the same setup. We come down inside of our dial, our initial dial. We set our 0s for depth. We set our 0 on the indicator, and we call our first one, our home position. Okay. So that's at 0. We're all set up. We're all locked down. We'll index it. It's the harmonic stop. We'll do the same thing. We'll come down to that depth, and we will, oops, not there yet. And we will see that the position of the first one is maybe 1/4 of a thousandth in the positive direction, which is not much at all. And we'll come up and we'll index. This next one is 1/1000th in the negative direction. One. It's back to just about 0. So what we do with these values is we pair them. The index table has an accuracy, and the dial plate has a machining accuracy, and when they're paired together, you get your total solution accuracy of when you put this into your facility, what you're going to get. So this is the best kind of report that we can see that matches with our dial plates. So we have a calculator of a report, and we put all these values that we measure inside of it, and it tells us if it's a pass or fail, and if it fails, we remanufacture the plate. If it passes, we send the report, and we send the plate out. This last test is a flatness report. We measure the flatness close to the station at every station, and we start with 0. And typical flatness we'd like to see here is within 5/1000ths. So you'll see like a hill motion on the indicator as you index thing around because of the material. But we start at 0. We do the same thing. It's a real easy process just to see how flat it is, and it matters at the assembly of the fixture. This one is about 1/2 a thousandth in the negative direction. for station 1, the same for station 2. We're at 0 for station 3, and station 4, or which was our 0, is back to 0. And that's real simple. That's all you do. That's a really flat plate. And this is the WEISS tool plate to index table unit measurement protocol. For this report, we pair the index table, which is this serial number, with the actual dial plate, which is this drawing number, and we measure those values where you can see it off to the right here. You can see the concentricity values at 4 stations that we measured. You can see the position or the division tolerance at 4 stations and the flatness. All those are recorded in inch for this report, and you get some line graphs showing it's in within tolerance, and you show the deviation as it goes around the plate in 4 stations. And we record here the total diameter of the plate, the pitch between the dials, the flatness required, the thickness, and at the end result it tells us if it's a pass or a fail based on the indexer that it's with, the number of stations, and the size of the plate.